Yeah, good morning all. Myself Neha Sathe. I am presenting my paper in International Conference on Recent Trends in Machine Learning, IoT, Smart Cities and Applications. My paper ID is 103. Paper title is Perceiving Correlation Among Spatiotemporal Gait Parameters and Verifying its Relation Using Machine Learning Classification Technique, Pilot Study for Indian Population. Outline of the presentation is it will go through introduction of a gait analysis, some important spatiotemporal gait parameters, database which is used to perform analysis, some brief about correlation coefficient, results of a correlation, machine learning test case, conclusion and references. So get an idea about what exactly is included as a part of a gait analysis is. Analysis is a clinically accepted tool which is going to provide or describe a quantitative measure about walking pattern of a person. So altogether, if system, appropriate system being used to record a gait pattern, we are able to retrieve a lot of information about walking pattern, which is termed as a gait pattern from recorded content. There are different methods which are used to perform a recording. It might be done with a visual effect, maybe using images, maybe using videos, or with the use of a wearable sensor or any kind of a pressure sensor. So depending on the method which is being used for a recording, analyzing process may alter. To understand gait analysis at the superficial level, it is necessary to understand what is a gait cycle and what are the different phases of it, as well as few important parameters which are named as a spatiotemporal gait parameters, which describe information about different sub-events in terms of distance covered and time taken within it. Typically, gait analysis is used in a rehabilitation process when somebody has undergone some orthopedic or post-stroke rehabilitation. Gait analysis is used. Now, in advanced applicability of a gait analysis is used in fall risk prediction, maybe for geriatric care or as a biometric identification. Moving ahead to know about the gait cycle phases, typical gait cycle gait divided into two major phases. One is specified as a stance which occupies 60% of a gait cycle while swing occupies 40%. Major events which are recorded or which are used for analysis include different heel strike movement of a left and right leg, phase starting duration for a stance and end duration of a stance, as well as how much duration system is going to utilize in a swing duration. These parameters are recorded for left as well as right leg separately as in a singular and bilateral parameters. Typically used most commonly features or parameters in a gait analysis include spatial category, which provides a description about a distance covered, mostly covers step length parameter, stride length, number of steps covered in a specific distance, and a step width within two legs, while most preferably use temporal parameters or temporal features which are going to describe a duration elapsed with to complete a particular event, and it includes step time, stride time, single support and double support time. This is nothing but for how much duration you are holding your body weight on a single leg and how much duration you are taking a support of a both leg. Stance percentage cycle and swing percentage cycle. So at a broader level, it will check out how much duration in terms of a percentage being utilized by stance and swing phases. To explore further about the spatiotemporal gait parameters, this is a visual explanation of it. So when we are going to think about a step length, it would be taken care that we have started with a heel strike of a right leg and we need to check out immediate next heel strike. So this is going to be a distance covered under step length. To know about the stride length, this is going to be a distance from heel strike of the leg if it is a right, then the repetition of a heel strike of a right leg only. Likewise, step width will be calculated by considering left and right leg. Moving ahead, to work out with database has been created or recorded using electronic walkway gait right, which is available with Dinanath Mangeshkar Hospital and Research Center within Pune, Maharashtra, India region. Contributing subjects are within the age span of 20 to 70 years and all are healthy subjects. There being no medical record for any disease which is influencing their gait pattern. Footfall is recorded with comfortable shoe wear as well as for a barefoot walk to know how things are going to vary if it is a barefoot or with comfortable shoe wear walk. Subjects being asked to perform a dual tasking means they are engaged in some communication. They are being asked to count down their number of iteration on their own just to assure they are able to manage 10 iteration in an appropriate way. Such recorded raw data being processed for further calculation. To know or to perform any analysis on the data, it is very essential to understand what exact relation do exist in the different features associated with the data. Do we have any relation within that one, or whether they do provide some anti-existence of a relation? Both are going in a different direction. Understanding these relation within features is very important point, and for that reason different ways of identifying correlation being used, as if Carl-Pearson correlation coefficient calculation, Spearman's rank correlation, or method of least square system which is being used to identify a correlation coefficient for this particular study is called Pearson coefficient of correlation, which is going to consider x and y variable, and by knowing how much variation and standard deviation both features are showing, it will be plotted as in no correlation among two parameters, positive correlation or a negative correlation, which is described on the scale of +1 to -1. Zero value obtained on a scale is specifying no correlation. Positive value indicate moving towards +1, specifies positive correlation. Means if feature 1 start increasing its value, feature 2 is expected to behave in a similar way. If it is going to show a negative correlation, if value is identified as a -1, then if feature 1 is showing an incrementing factor, feature 2 will start decreasing its value. So on the basis of this one, some case studies being taken care to evaluate performance. Here, one result obtained through correlation study is shown considering age of a subject and walking velocity. So plot is showing number of subjects which are indicated with a blue line. So with an increase in the age, walking velocity start decrementing linearly, and this is a very important identification throughout. So as age progresses, aging effect reduces walking velocity across all subjects linearly. Now to explore more about how aging influence changes gender wise or age group wise, classification or separate analysis is done for a different group. First consideration is, do we have any variation in a male and female behavior? Then yes, this plot shows how things are correlated in a male and female category. Blue column is indicating performance of all female subjects, while orange is showing a value for a male. If we can check out, higher values of negative correlation are observed in a female subjects in comparison with a male. So aging, we can say that aging effect is bit dominant for subjects within a female category, and this is a performance with reference to different age values. So all are showing a negative value, providing assurance that with the increment of age, your walking velocity start reducing. Age and cadence correlation being verified. So with age increments, correlation shows that cadence values start decreasing. So number of cycles which are completed start decrementing as a cadence ratio. Moving ahead, correlation of leg length and step length is verified. So definitely if a person is going to have a higher leg length, must be able to cover a more distance as a part of a step length, and same results are obtained when it's being verified within an age group as well as within a gender category. Both shows a positive correlation. So definitely with higher height system, each one is able to cover higher step length or a distance. With obtained correlation, test case was executed to classify provided data set into two age group, 20 to 45 and 46 to 75, considering mostly after 40 plus or rather from 45 plus aging effect starts get influencing in each of the activity. So performance of different machine learning classifiers are tested, support vector machine, logistic regression and KNN are tested, and SVM and logistic regressions are able to provide classification accuracy up to 62%, while KNN is able to provide accuracy till 75%. Depending on number of database entries which are going to change within an age group, this classification accuracy may vary. So to conclude, age and walking velocity shows aging effect on all age group and shows decrementing it linearly. Age and cadence also shows a negative correlation coefficient, indicates with aging it influences cadence. Leg length and step length shows a positive correlation, specifying with a higher or heighted person is able to cover positive or more distance than a person with less height. Comparatively, effect of aging on a spatial temporal parameter is being observed dominant in case of a female subject than a male. Walking velocity, step count, cadence are important decision making features in an aging effect. Thank you everyone. These are the used references. Thank you.